building on, because so yesterday we were just kind of looking at patterns, and I just wanted you to get a bit of experience playing with different patterns and looking at sequences and things. So we're going to go through a bit more terminology today, and then we're going to do some proper questions from the question book I gave you. So it might be handy to have a pen and a highlighter handy as well, because we'll go through a bunch of words to go with all of this as well. So this is on page 3. So Sienna, page 3. Okay. Okay, so yeah, page 3. Okay, so key words here. So we've got a sequence. Okay, so you can highlight what I highlight. Is a list of numbers in a particular order. So we were coming up with different number sequences yesterday. So the numbers or items in a sequence are called the terms of a sequence. So remember yesterday I showed you T1 is the first term, T2 is the second term, and so on and so forth. Now they can be random or we can use a rule. Okay, so yesterday you were kind of just following the pattern of what was happening in the different sequences. So we can have randomly generated sequences. So, for example, recording the numbers obtained while tossing a die will give a randomly generated sequence. So, if you roll a dice, these are the random numbers you can get, but you can't predict what's going to happen next. Like I could roll another stack of 3s, I could roll a 1, but you can't guess. So, that's what we call random, if we can't guess what comes next. And then rule-based sequences, which is what we're going to spend a bit more time on. So, for example, writing down odd numbers starting at 1 would give you the sequence generated by a rule. So you've got 1, 3, 5, 7, 9, 11, and 13. So what's happening here? Adding 2. So, it's written down there. So there's a rule that allows us to find the next term in the sequence. So we want to add 2 to the current odd number. Okay? So we're adding 2 to the current odd number each time. So, for example, to find the term after 13, so if I want to know what the next one is, we're going to add 2 to 13, and that will give us, oh, you right? Bless you. 15 is the next sequence. Was that a hiccup? Yeah. Okay. Yeah. So we can keep going by adding 2 each time. Now, down the bottom, it says a group of 3 dots. So at the end of a sequence, you put in like 3 dots, and we call that an ellipsis. Okay, so it's used to show that the sequence continues on indefinitely. Okay, or sometimes you might write some terms at the start, have some stuff in the middle, some terms at the end. So just to show that it continues on. Okay, all right. So example 1, it says look for a pattern or a rule in each sequence and find the next number. So what's happening? Can anyone see what's happening in this sequence each time? I'll zoom in. Yeah, nice. So we're adding 6 each time. So 6 plus 8 is 14. 14 plus 6 is 20. So we are adding 6 to the current number. Okay. And then what's the next term going to be? Yeah, good. So the next term is 26, and we'll work that out by doing 20 plus 6. Okay, and I'll show you ways to actually work that out. Like, I know you're looking at it, some of you can't be like, how did she work that out? We're going to teach you some strategies to work it out as well. Now, this next one, can anyone guess or see what's happening with this one? Times by 3. Yeah, good. So each one is times by 3. So what's another word for times? That's a bit better than multiply. So we're going to say multiply by 3, the current number. I should probably write current number. It's bad English, actually. So then the next term, can someone work out 135 times 3 for me? Is 405. So we've worked that out by going 135 times 3. Okay, good. Okay, how about the next one? Trinity, you're good at this. All right, take away 3. It's all right. Some people have an eye for it. Some people don't. It's okay. So we're going to subtract 3 from the current number. Good.
Oh my god.
She's like psychic.
I'm
Good.
saying oh my god because she keeps hiccuping.
Oh, that's okay. Oh well. You can't control that stuff.
Can I go to the tap?
Yeah, you can have a drink. Yeah. The next term is, so we've got -2. What's my next term going to be? Take away 3. -5 becomes more negative. So we're going to go -2 minus 3. Okay, so this next one, the next 2 are a bit tricky. So I'm just going to tell you what the sequences are. Yeah, go on.
Times it by 3. No, and then +1.
Times by 3 plus 1. 4. So what works for the first one? 4 times 3 is 12 plus 1. But yeah, it's worth a shot. This one is what we call square numbers. So what it actually is, it's 1 squared, 2 squared, 3 squared, and 4 squared. So I'll just say square the current term. So yeah, so the next one would be 5 squared, which is 25. Okay. Don't really see a lot of D, and we won't be doing much. We won't be doing anything on that kind of stuff. But that's just something to show you. And then the last one is a special one, which you probably won't see again this year, but you might see it next year. This one's called the Fibonacci sequence. How do you spell Nachi? Fibonacci sequence.
Went up my nose a bit.
That's great. Okay. So then what we do is we actually add the 2 previous terms. I'll write that down. So add the 2
Is that another language?
previous terms together. So for example, I go 1 plus 1 makes 2. 1 plus 2 makes 3. 2 plus 3 makes 5. So then my next one will be? So the next term is 8. Next term is 8. So because you go 3 plus 5. So you add the 2 terms before. Add the 2 previous terms together. Okay? So yeah, just showing you a whole bunch of different sequences. Okay, so then, is that okay? Any questions?
Leave it for like a second.
Yeah.
Square the current term.
Yeah. All right, Sienna, you can get off that now. Okay. So then, underneath, so naming the terms. So I talked about this yesterday. We use these symbols to label the first term, second term, and third term. So let's just highlight them just to show what they look like.
What does it say?
Fibonacci. Yep. Fibonacci. Yeah, Fibonacci. So the numbers at the bottom are what we call subscripts. And that's just how we label first term, second term, third term, and so on and so forth. Okay, so the number at the bottom tells us what the number in the sequence is, like which number it is. It's the 8th number, 10th number, or whatever. Okay. All right, cool. So over the page. Okay, all good? Okay. Liv? We'll catch you up later, Sienna. Yep. Okay. All right, so on the next page it says, for the sequence 1, 7, 13, 19, 25, 31, state the values of, so what's T1? 1. So T1, I'll just put some equal signs in. So T1 is equal to 1. Okay. Because this one here is T1, this is T2, and so on and so forth. T3, and so on. So what's T4 in this? 19?
There's only 6 numbers. So
Yeah, I know, that's annoying, isn't it? So can we see the pattern?
Yes. Oh.
T6. Oops, sorry, getting messy.
Adding
What's the
6?
pattern? Yeah, adding 6. Adding
So
6.
37.
So then, yeah, so it'll be 31 plus 6, which is 37. You could just write the number. I'm just showing you, writing it down so you know, if you look back, you can see how I worked it out. Okay, good. So the first type of sequence we're going to look at is what we call arithmetic sequences. So when we look at arithmetic sequences, it's basically adding or subtracting. So arithmetic, the word arithmetic refers to adding or subtracting a fixed amount to the previous term. So I'm going to give you a technique to work out what that number is each time. If you can't necessarily see it when you look at it, then I'm going to give you a strategic way to work them out. So there's some examples of arithmetic sequences. Sienna, you can shut your laptop now. So that amount that we're going to calculate is what we call, and you highlight this please, the common difference. And the letter D represents that number, that difference between each number. So whatever number you're adding on, whatever number you're subtracting by each time is called the common difference, okay? So to work it out, you basically look at two terms that are next to each other and you subtract the latest one from the earlier one. I'll show you what I mean by that. So down here, it says find the common difference for the following arithmetic sequences and use it to find the fourth term in the sequence. So to begin with, I'm just going to write the names of each one down. That's fine. Yep. So there's 3. So I just want to label them just to kind of show you what I'm trying to do here. And what you do is you just pick 2 numbers that are next to each other. So I'm going to start with doing 7 and 4. Okay. Now to work out the common difference, and this is how you set it out, we subtract the later term, so T3 minus T2, like that. And then you put the numbers in. So that's equal to 7 minus 4. And that makes 3. And it's important to do it in that order. So it has to be the later number minus the earlier number. There's a reason why we do that. Now, I always say you should do it more than once because, you can see it in it'll happen once, but it needs to happen more than once, is what I'm trying to say. So we will also do 4 and 1 because they're next to each other. So we do it again. So T2 minus T1, which is 4 minus 1. And can you see that the common difference is the same? So we've worked out that each time, what this means, so D equals 3, is each time we're adding 3 to the current term. So I'm going to just write it as a sentence as well. So I'll just write, therefore, D is the common difference is 3. And I'll just put it, you don't need to write this when you do it, but I'm just going to write it as a sentence just to show you. So we're going to add 3
Why
to...
do you put the 3 dots in?
Oh, it just means therefore. It's just fancy maths. Yeah, just write D equals 3 will do. So add 3 to the current term. Sorry, it's just makes me look smart. It's like the symbol for therefore, like in summary, equals 3. So we are going to add, so what it's saying is add 3 to the current term. Okay. So you need to work out the common difference twice with two sets of consecutive terms to say that that's what the common difference is. So you can't just do it once. So the next one, Sienna, shut the laptop. Thank you. Right, so the next one, do the same method. So we've got 3 numbers there. I'm just going to label them for the sake of me just making it obvious. You'd be doing this in your head. Pick 2 consecutive terms. So let's start with 22 and 24. So the common difference is T3 minus T2. So
why do those 2?
as long as they're next to each other. So you can pick any set as long as they're next to each other.
Do you always have to write 2?
I'm writing it. I'd say do it today, but then after that you can do it in your head. Yep. So 22 minus 24 makes negative 2. Okay. We're going to do it again. So let's pick the other possibility here, 24 and 26. Obviously, if you've got 5 numbers, you can pick any 2 as long as they're next to each other. Okay. So D is equal to T2 minus T1. So that's going to be 24 minus 26. So that's also negative 2. So that means that my common difference, is equal to negative 2. What does negative mean? What's another word for that symbol?
Minus.
Minus. So if I wrote that in words, what's happening? Subtract 2 from the current term.
Why couldn't you 26 from minus 24 so it wasn't odd? And so it wasn't a negative number.
Yeah, so if you do it the other way around, because if you can see in that original sequence, the numbers are actually going down. So if you do it the other way around, you're actually showing that you're adding 2, but it's actually subtracting 2. So it's kind of a foolproof way each time to say you don't have to worry about the positive and negative sign. I mean, you can see with these sequences are pretty easy, so it's really easy to see that it's going down. But later on, as they get more complicated, because that one's +3, like you might need a bit more. Yeah, it's just like a technique to kind of make sure it's accurate, I suppose.
What if there's more than one operation?
More than one operation. Oh, yeah. So it's not an arithmetic sequence then. Okay. So if you have different answers, it actually means, and that's actually our next example. That just proves it's not arithmetic. It's not a sequence that has a pattern. So it's random or something. Okay. All right. Cool. Over the page. One more page, I think. So that leads on to Danielle's question. How do we know if their numbers are different? So let's just pick a couple of numbers from each one, work out the common difference. So let's do 28 and 21. So I'll just do 28 minus 21. That makes 7. Okay. I'll pick another 2 numbers that are next to each other. Let's just do, you can pick any 2, 42 and 35. So I'll do D equals 42 minus 35. That gets 7 as well. So because they're the same, so therefore this is arithmetic.
So it's
Arithmetic, yeah.
It's arithmetic if all of them equal 7.
Yeah, so if all the common differences are the same. Okay, if the answers are all the same, and I could do it a third time if I wanted to, and I'd get the same answer. Okay, and yeah, you can pick 35 and 28 as a pair as well if you wanted to. Just any 2 that are next to each other.
Wait, obviously they're all going to be the same. So why are they making us do this? Because it's patterns.
No, they're not all the same.
Oh, it's like trick.
Sometimes they're not.
Oh.
Yeah, that's why. So for example, like this one, chances are this one won't be because you have to show you one that's not. So let's do 6 and 2. So 6 minus 2 is 4. So that's the first one. And just for my interest, I'll do 18 and 6. So 18 minus 6 is 12. And can you see here, they're different? So therefore, this isn't an arithmetic sequence. So this is not an arithmetic sequence. Okay.
So do we always go right to left?
Yep. So you always subtract the right one, like right one minus left one. Yeah, you could jot that down if that helps you to remember. So it's always the right one minus the left number. But the numbers have to be next to each other. So you choose 2 numbers next to each other, right minus left. Actually, that's good. I should do that in my notes for next time. Okay, next. Kaz, grab it out. I need to turn mine on. Don't worry, I've got 3 today, so you may need to share if we don't have enough to go. Alright.
Can I just?
As long as you can look at C1, why not just pass?
Can we share one?
Yeah, and then pass it. Anyone else even on this side? I'll just use this now and then you can go get it.
I don't want to use it.
Okay. This won't take me long to show you anyway. So we can also generate the sequences on the. If I can just get it going. Whoop. Oops. Okay, so we can also generate the sequences. So when my calculator works. So what I want you to do is, can you go to a calculator page, a fresh page? So go to a fresh calculator page for me. Just look on so you can all see. You can grab it when we start doing work. Just give it a minute. It's thinking, I think. Hasn't been turned on for a while. All right, so here's mine. So okay. So we can generate the sequence as well if we know what the common difference is, if we know what D is. So in this one, I want you to start by pressing 2 and then, important, press enter straight away. Okay. Now let's just say for this sequence, we're going to add 5 to each number. So you go 2 and then enter to kind of save the 2 into the calculator. Then you can go plus, and see how it says answer, 5. Oh, so you just press 2, enter. So it saves the 2 into the calculator. Then I just want you to press plus 5 and then enter. So it brings up the second number. And then you can just keep pressing enter and it gives you the sequence. Yeah. Right? But this is what I see people do. So that's the right way to do it. What I see people do is do this. 2 every single time. Someone's going to do it in here after. 2 plus 5 equals, and then they go plus 5. Oh, it does still work. Okay. Sometimes it doesn't work.
Wait, so what's the cool way?
Nah, so you want to do 2, enter. Oh, God. Hang on. 2, enter, save the 2, plus 5, enter. So it gives you first term, second term, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. Okay? Now I say this is the best way to work out your first 10-ish terms, because after that people lose count.
But can we scroll up for a second?
Yeah. So just go 2, enter.
So why don't you go straight to 2, 7?
Because then if you need to scroll back, you've got the sequence all on the right-hand side.
Oh, so when it equals is what?
Yeah, that's the sequence. Yeah. Okay. So that's a way to generate it on your CAS. Now, is there any more pages? One more page. Okay. Oh, this page. Yes. Last one. Where are we going? Oh, let's just do it. Let's just do it. Get through it. Okay. Last thing. Huh? And we might need to continue this on Monday.
I'm telling you, grab it. Just grab it.
Highlight this formula. So that calculator way. Okay, so that calculator way is really good if I say, can you find me the 8th term if we're adding 5 to every single number? But what if I say, find the 50th term? So you go hit the thing 50 times and hope you don't lose count, all right? This formula is what I would recommend you use for anything above about 10. Because after 10, people tend to lose count, all right? So we use this formula, Sienna, to work out anything beyond the 10th term. So, and some other things as well. So, for example, number 6 says find the 30th term of that particular sequence. So 20, 17, 14, 11. So the way we do it, the first thing we need to do is find what we call A. So A is defined as the first term of the sequence. D is the common difference. So that's the amount you're adding or subtracting by. And then the N is your position number of the term. So it actually may be worth highlighting these definitions as well. Okay. So, but the formula will help you work it all out, and we'll be using your CAS to solve it as well. So we've got find the 30th term. So the first term of the sequence, which is A, what's the first term in this sequence that's listed here? 20. Okay. Then D is my common difference. So we need to go through that process I just showed you. So we've got 17. So I'll just do it on the side here. So 17 minus 20 is negative 3. And I'll just do another set. 11 minus 14, is negative 3. Okay. So my common difference is negative 3. And then what position number term are we looking for? The 30th term. Good. Okay. Now, last thing, I'm going to stop after this example. So then what we do to find the term is substitute those numbers into this formula. So I'm just going to write the formula out. Minus 1D. Guys, come on. Can we stop? So N is 30. So we write T 30 is equal to A, which is 20. Guys, can we stop talking, please? A, which is 20, plus N, which is 30 minus 1, and then D, that there is a times -3. So you worked out the first term of the sequence, the common difference, position number of the term. You're substituting all these letters into that equation I gave you. Yep.
What would you do for common difference?
It's not an arithmetic sequence. So you either stuffed it up or it's not an arithmetic sequence and you wouldn't use it. Yeah. Okay. Okay, so then from here, in your calculator, can you just work it out? 20 plus 30 minus 1 times -3. And if you want to, no, just work it out. Just 20. Memorize?
Yeah. Oh, having enough something.
Yeah.
Yeah, but
You put it in your summary book. Yeah. Look, as long as you got it in your summary book.
wait, just don't move.
So
Can you explain what you did?
the one that I was talking about while you were talking the whole time. Right. So I'll just solve it here. So it'll be 20 plus
So is it always going to be that formula
30
to work out?
minus 1. That's a bit rude. Times -3. Okay, so -67. So the 30th term in this is -67. That's it. Okay, so I'll say it again. So you've got this formula over here. You need to find the first term, common difference, and the position number. If you can start by writing out what they are. So write what A is, what D is, and what N is. Substitute it all into the formula. That'll give you the 30th term or whatever term they ask you for. Okay? All right, I'm going to stop there. Today we're going to start working through set 2 questions. I'll gauge how we go in terms of how we work. Okay?